here we are actually segmentize the output that they have into very specific core subjects. Okay. Here you can see that we have different subjects. We have heat and mass transfer, thermodynamics, and unit operations. Those subjects are actually giving detailed design of various equipment that we have. So we actually segmented their output from here and put it into the context of these courses. And then what happened is that after that we are actually revising. The group will revise their output and put it together, and they are producing another output, which we call as the process flow diagram. Okay? And prior to their submission, their integrated design report, which is actually the supporting course for capstone, they are actually infused with professional training at INSTEP. They are also infused with some safety information, and we also expose them to simulation tools which are actually used in industry. For example, Microsoft Excel, Visio, AutoCAD, and ESCO. And at the end there, you can see that we are actually getting the reflections from both students and industry on their attributes. Alright, this is just an example of how we actually prepare our design instruction. Sometimes it's a 3-page instruction that we actually prepare, so that it is actually just a guide for the student to start and embark their work. Alright, this is a first student output that we have in the year 1. In engineering, we call this as a common block diagram. Okay, so throughout a 42 hours contact that they have as a face-to-face facilitative session, they are actually coming out with this process, and it is actually different for different groups, and they actually come out with these detailed calculations, and it is also different for each group. Okay, let's move and see what are the difference between this figure here with the next one. Can you see the difference between the two? Yes, right? You can see that now the students are able to integrate some of new units there because of the incremental knowledge that they had gained from the previous subject. So here what we did is that we introduced the utilities, which are water and electrical consumption, into the context, and what they have to do is they have to recalculate everything. That is what we call as an iterative process. Okay, the second iterative process occurs here. This is actually a sample of a chemical engineering drawing work, where we are actually draw the block diagram into a commonly professionally accepted block diagram. Okay, so here they are using Visio. Previously they just used box in Excel, now it is actually upgraded to Visio. Okay, the diagrams are becoming more complicated now. So you can see that these are all symbols that are actually widely accepted in a professional engineering diagram. This is actually an indicator that our students are actually already exposed to the iteration method, and they are also actually increase or improve their knowledge in engineering or in the technical domains. So here I'm just actually do a very simple simulations or representation of the improvement that they have done. From a very simple block diagram, they are changing it to a commonly accepted engineering symbol to represent a heat exchanger, and then for the next step it is a heat exchanger combined with what we call as auxiliaries. Auxiliaries means something that is actually added to the unit. And we have another one there which is a detailed heat exchanger design that comes with control, that comes with other auxiliaries that is required for the heat exchanger to operate. These particular diagrams are very important, especially if the company want to make a purchase of the heat exchanger system. So what are the impacts? This is what the students tell us. Alright, this is what they feel when they have this kind of experience. They feel that the prior learning is very important. The experiential learning is very important, and what we have provided to them actually gives them the opportunity to experience what capstone is, even though this is just a small scale of a capstone. Right? I would say it's just a small scale of a capstone design. And when we actually ask them how do they reflect in terms of their knowledge, right? So this is actually the number of students that the number of population that we have here is about 51, right? Because it represents year 3 and year 4 only, because our year 1 and year 2 is not in the full cycle. So we actually look into the fundamental theory grades for test, data extraction and analysis, and if they are actually mastering the knowledge when they collaborate. So these are all their response to us. So we say that a number that gives about 75 to 100 is the happiest number, alright? And we also look into affective domain. Okay, in our particular practice, we actually require students to have what we call as a team design logbook, a team design portfolio, and a personal design logbook. Both of these is actually a common practice in engineering practice, because it helps the student on capturing and keeping their information, keeping their calculations carefully as what should be actually documented by engineers. So one of the elements that we have here as well is communication, valuing how do they value the knowledge that they actually get from this experiential learning, teamwork, team dynamics. And a very good response that we have on organizing means that they are actually making a priority of engaging and completing the task even in this project compared to the others. You can see that it's quite high, right, for 75 and 100%. Okay, we are looking also on the psychomotor domain, okay, the skills of doing, whether the iterative actually helps them, okay, and we are looking into various data gathering and data handling informations, and also the use of tools, Aspen, Excel, Visio, and also manual drawing. Okay, these are just our students' perspective. They say that they have a good bird-eye view on the project and it helps them, right? And our faculty perspective, when we have this kind of project, what we do is that we actually reduce the workload of the student, because we are consolidating and we are focusing. So we are actually removing all those all the materials that are redundant. Okay, we are focusing on very focused engineering issues, focused imaging issues with respect to design. And it is also actually a better synergy among the courses that actually involve people, environment, assets, and reputations. This is the most interesting one. We get industrial feedbacks, and they said that our students are well trained, especially in problem solving. Indicates something to us that the problem solving skills that we provide to them is actually benefiting them. Okay? They are good in planning, they are very resourceful, they are very tactful, they are good in data analysis. All of those are actually a nurtured skill compared to a nurtured skill, right? We can say that someone who is hardworking is already hardworking, but students who are coming in are not good in planning, especially in dealing with complex problems. So it comes from the training that they had actually undertaken in their previous years. Okay, dear colleagues, what we did is not easy, right? This is just a take-home notes from us. We started this actually in 2016, even before we actually started it a bit by bit, but we didn't document it. So in 2016, we tried this scaffolding system, we call it. it starts with just 2 years of a year 1 course and two courses of a year 2 course. So we try to put together what we can sync, what we are actually doing it the same thing, and we try to reduce the workload on the students. And we are actually progressing. We try to encourage many more people to come in and join us, help us so that we are able to make sense of the knowledge to the students. Okay, making sense of the knowledge to the student is very important because all of these are abstracting. If we are not trying to make sense to them, then there is no one for them to refer to. So in 2018, we are actually putting in 3 year 1 courses, 5 year 2 courses. And then we also infuse a prototyping approach and a professional training that we conducted at INSTEP. And in year 2019, we have 5 year 1 courses and 6 year 2 courses. Now our prototyping is actually infused with 3D printing and also professional training. In the future, our direction is to have a multidisciplinary approach. We know it's difficult because we have to tackle people from other departments, from other faculty who might have a different perspective. But we will try, and one day we might approach you. Okay, with that, I would make a very special dedication and thank you to our Dean of Engineering for giving us the opportunity to present our Deputy Deans of Academics, right, Head Department of Chemical and Environmental Engineering, Engineering Education Interest Group. Just in case if you don't know the existence of this group, we have it at Faculty of Engineering. Okay, these are the teams, these are just department photos, and the people who are actually coming up and work to produce these are actually written there. I don't need to actually mention them, they know who they are. But our special appreciation goes to our students, our co-curator, our co-designer, and our actor and actress of this immersive learning, experiential learning. Without them, if we have a very good system, if they don't actually follow, then it won't actually make anything of. So just a very simple video. Thank you. If you want to ask questions while the video is there, there's a day we can ask questions. Thank you.
kasih diucapkan kepada Fakulti Pencitraan. Seterusnya adalah sesi soal jawab dan komen daripada penguji. Terima kasih.
Assalamualaikum. Tahniah Doktor di atas